methods, research methods, the three main types. All right, but first, before we begin, remember on the scientific method, psychology is mental processes, which is sometimes difficult to measure. But remember, science always wants to be empirical, which means observable or verifiable. But they need to test their theories, they need data. And once they get that, they'll create a theory that will explain something from happening. And there's three main types of research methods that psychologists use. You want to be really familiar on all three of these. Remember, one of the essays, pardon me, one of the free response writings is going to be about science. So this is going to be the most important unit of study. First big type of research is called descriptive research, and it's just like it sounds. It describes. It's empirical. It looks for data, but it describes reality such as a natural observation. Here, this woman is observing the chimp, and she'll make observations. She'll have data that would be a natural observation. Another type is called a survey, which measures thoughts. They can ask you a question like, what is your mood right now on a scale of 1 to 10, and we could measure it. Magazines do it a lot. With surveys, you want to be careful of sampling. A random sample means the people in your study are there by chance. So you got to be careful of that with surveys. If I ask students, tell me how you did on the AP exam, usually the people that did well will respond. That's not a random sample. So be careful of your sample. All right. And surveys are good for private things like racism, sexualities. That surveys are good for those kinds of things. Okay, another type of descriptive research is a case study, and that would study a person, an individual, or a group of people in depth. And that's Phineas Gage, the famous case study about brains. All right, that's part one. Part two, correlational research. You want to know this one really, really well. Okay, correlational research is you take two variables and you look for a relationship. Do they go together? Do they rise together? Do they fall together? Is there more crime when it gets hot? Do people grades go up when they study? It's always two variables, but remember, correlation, and know this one, it probably will be on the exam, it never shows causation because there could be a third unknown variable. It's predictive, it shows relationships, but it never, ever, ever shows causation. All right, for example, hot weather and crime is a positive correlation. The hotter it gets, the more crime there is. The cooler it gets, the less crime there is. TV and vocab is a negative correlation. The more TV someone watches, the lower their vocabulary is. But remember, TV does not cause a lower vocabulary. There could be a third variable. All right, with correlational coefficient, that gives it a number. The larger the number, the stronger the correlation, and then plus or minus just shows direction. So the strongest correlation is at 1.0, 0.9, 0.8 is extremely high. Low correlations would be 0.1 or 0.2, and 0 is no correlation. There are negative correlations and positive correlations. If they ask you for a correlation, go to the number, the strength. All right, that's the SAT is plus 0.55. Negative 0.46 is TV and vocab. Everything is correlated to some extent. Plus 0.03 is extremely low. All right, remember, positive correlations, the variables go the same direction. The higher the SAT score, the higher the success in college. The lower the SAT score, the less chance of success in college. And a negative correlation is inverse. It goes opposite directions. The more hours of TV, the lower the vocab scores. All right, you can graph correlations like this, and it turns into what they call a scatter plot. Basically, this is a perfect positive correlation. Starts low, getting higher, positive. Perfect negative correlation. It's going downhill, but it's a 1.0. In here, there is no correlation. This shape of diagonal, or more frequently, it's what they call an elliptical shape. That pattern shows a correlation. Here, what do we have? A little bit of a positive correlation. Not much. All right. Then the last big one, experimental research. So part one was descriptive research. Part 2 is correlational research. Part 3, experimental research. It is the only way to show causation. And it's the only way to show cause and effect. And what you do is you take variables. You're going to have an IV and a DV. The IV is the cause, the DV is the effect. Experiments are always about cause and effect. Does something cause something to happen? So IV is cause, DV is the effect. And then what you're going to do is you take your two variables, you're going to put them into groups. You're going to have two groups. An experimental group will get the IV, and then to check it, you have a control group, and that'll get a placebo. Remember, in an experiment, all variables are identical except for this one. The only thing different is the IV. Everything else is going to be equal. So you will give the IV to the experimental group, you'll give a placebo to the control group. So continue here. Now, staying with groups for a second. Random assignment is how you get people into groups, into the experimental group or into the control group. Careful, don't confuse that with random sample. Sample would be the people. Random assignment is how do I assign someone to the experimental group or to the control group. It must be random. I take people and flip a coin. Heads, they go here. Tails, they go there. I put their names in a hat and then I pull them out. It must be random. I can't put people in this group that I want to put for some biased reason. So that's random sample. Okay, I have two variables. I have two groups. I have the people in the groups. Now I can do my experiment, and let's say I have a pill to give you a perfect SAT score, and I gave you my pill, and I gave you I gave the control group a placebo, and I gave you guys, and I said my pill will give you a perfect SAT score. At the end of the day, 90% of these people got a perfect score. 10% of these people got a perfect score. Everything was equal. Did my pill cause it? Apparently, yes. Why? Everything was equal except for the pill. They got 90%, they got 10%. The term they use is statistical significance. The numbers will always be different. Is the different number statistically significant beyond chance? Here, clearly, yes. All right, one more time on this, just to review. When I design an experiment, I start with my population. Let's say I'm doing research at UCLA. My population would be UCLA students. Then I get 100 students to put them into my experiment. That would be my sample. It's the 100 people I took from here. I'd get a random sample. Then I need to put them into the experimental group, control group. I would use random assignment. So random sample for the population, random assignment into the groups. And that would be my research. Those are the big ideas: IV, DV, experimental group, control group, and then statistical significance. Now, if I do one study that's nice, for it to be real science, it needs to be replicated. And what replication, all that means, just like it sounds, someone copies my experiment. They do the exact same experiment. Do they get the same results? If I do one study, great. But if there are 10, 20, 30, 40, 50 studies and they all get the same results, now you have really solid science, and that's called replication. Now, operational definitions confuse people, but it's very basic. All it is the numbers given to the variables. So an operational definition would just be the amount of drug I gave to the group. That would be an operational definition. And what operational definitions allow us is it allows people to repeat my experiment. Okay, a couple other things. You've got to be careful of experimenter bias. Experimenter bias doesn't have to be evil. It's just like it sounds. Is the researcher slightly biased, maybe even unconsciously? Is he being perfectly fair, or is he in some way biased? That's called experimenter bias. And again, it's not evil. It could be something like, frequently something like, if the researcher is required to do something subjective like analyze a group, is he analyzing it fairly or is he slightly biased? There's a very good way to get around this called a double-blind experiment. The subjects in the experiment never know what's going on. In a double blind, the subjects don't know what's going on, and the experimenter doesn't know what's going on. That's called a double blind. All right, and then on occasion, just be aware there is something called a confederate, and a confederate is somebody that might be helping the researcher. Okay, those are the basics of the three types of research. You want to know those really, really well. All right.